Excellent. Well, welcome everyone to our workshop on the Regional Resistance Management Plan for Southeast Asia under the ASEAN Fall Armyworm Action Plan. My name is Dr. Alison Watson and I'll be your moderator today. And we have a very busy agenda. We've got an exciting lineup of international speakers to help guide us through this topic. We have saved time, however, for your questions. After each speaker has spoken, there'll be an opportunity then to ask your questions and have a dialogue with each of the speakers. Now, before we start, I just want to tell you how to use the platform today. I also want to underscore that a recording of the webinar will be made and we will distribute that at least or within 1 week after this session. And you'll be able to go to the ASEANFAWaction.org website and to the Regional Resistance Project page, and you'll find that recording there. So don't worry, you will be able to view this again. For today, if you have any technical issues, I'd like you to maybe send a message to Grow Asia or send a message to Pranav and just share with us what is not working, and we should be able to fix it. Otherwise, you can try logging on and off. Number 2, if you could rename yourself, that would be great if you need to. If you could put your organization behind your name, that would also be helpful so that we know who we're speaking to. 3, this is the main way we are going to have a dialogue today, and it's really important that we get lots of questions and that we actually really talk about what people want to know, what you want to find out, what you think could be part of this regional action plan as well. So please use the Q&A box to ask your questions to the speakers. Now, if you want to just chat, for example, you want to make a comment, you want to thank a speaker, you want to share a link or some resources that you have or highlight an important point, you can do that in the chat, and we also really encourage that as well. Now, of course, the main way we'll be actually interacting is through the Q&A box. There is a bit of a limited opportunity for speaking, and you'd raise your hand, or if you've got a problem, you can raise your hand as well, and Pranav will see that. Okay, so I'm going to move on very much to our sort of first introductory speaker, and I'd like to introduce you to Dr. Andy Triciano. Andy is a member of our project committee that developed our concept paper. He is a professor in entomology in the Department of Plant Protection, Faculty of Agriculture at the University Gadjah, Mada in Indonesia. Andy has over 20 years of experience working on resistance-related work, and we're very pleased to have him taking a leading role in this work. Andy, welcome.
Well, thank you very much for the introduction, Alison. Today, it is my pleasure to introduce you to our workshop on a regional management plan for resistance management under the Asian Action Plan on Fall Armyworm Control. Over the last 6 months, a small project team has convened and developed a concept paper for this important work program. And I would like to thank to all the members of that project team for coming together and supporting that effort with your time and input. Today, we would like to share with you important work, research, and resources on this topic that make up our work in the concept paper. But firstly, I want to emphasize why resistance management for fall armyworm is important to all of us. Farmers need a range of effective, economic, safe, and acceptable approaches and technologies to control fall armyworm. A regional resistance plan is vital because we need to ensure that fall armyworm population don't become resistant to different tactics and measures we have in our IPM toolbox. This is because fall armyworm, like any other insect, can acquire resistance to certain measures, and that resistance, once developed, takes away the power of this solution to control fall armyworm effectively. A coordinated regional approach is very important to prevent this resistance developing because fall armyworm is a fast-moving transboundary pest. Therefore, we are only as strong as our weakest link in managing fall armyworm resistance. The proposed regional approach to resistance management, therefore, focuses on 3 specific areas: regional fall armyworm surveillance and resistance monitoring. Second, country-specific and regional fall armyworm resistant management guidelines, inclusive of all possible IPM practices. And the last one, integrating host plant resistance with other compatible IPM tactics for sustainable fall armyworm control in the Asean. You will hear all about all those three components today. Dr. Prasanna Boddupalli from CIMMYT will be starting with a presentation about host plant resistance, the important and opportunities in this work for our region. Dr. Srinivas Parimi from IRAC will be expanding and explaining the current management practices and resources and what are important considerations for resistant management. We will then have three speakers from Australia, US, and China presenting on the latest status and research on fall armyworm resistance. How can you be involved? You can download the concept paper and comment on the activities proposed by going to www.asian. We have also sent the concept paper to the government representative in each of the 10 Asian countries. I know that Alison also emailed all registrants yesterday with the link to the paper. Most importantly, make the most of the opportunity to ask all your questions in the Q&A box and to share your thoughts in the chat box. And now, I'll give back the speaker role to Alison to introduce our first speakers. Thank you.
Thank you very much, Andy, and thank you for that very good introduction. And Andy will join us at the end also to provide a summary of the discussions today. So I look forward to that, and thank you very much for your work and your contribution to the concept paper and project group so far. I'd now like to introduce Dr. Prasanna, Director of the Global Maize Program at CIMMYT and the SGIAR Research Program on Maize. Prasanna leads CIMMYT's Global Maize Program, which focuses primarily on maize improvement in sub-Saharan Africa, Latin America, and Asia. And he provides technical oversight for an array of multi-institutional projects great, he's already there. On the development and deployment of improved stress-resilient maize germplasm in the tropics, as well as novel tools and technologies for enhancing genetic gains and breeding efficiency. He is also a lead technical expert within our Asean project group on developing the regional management plan for resistance management. And it's always a privilege to have you join us, Prasanna, so welcome. And I'm just going to stop share and let you load your presentation.
Thank you, Alison. I hope you can see my presentation.
I can.
Okay.
It just needs to be put on full screen.
Okay.
Excellent. Thank you, Prasanna.
Okay, first of all, thanks a lot, Alison and the ASEAN for giving me this opportunity to speak on fall armyworm resistance management in the ASEAN and what's the role of host plant resistance in a crop like maize, which is deeply affected by this devastating transboundary pest. Insecticide resistance in fall armyworm populations has been now one of the major topics of concern, and several publications have emerged recently on probing the genetic structure and insecticide resistance characteristics of fall armyworm populations in different countries, especially, for instance, in China, as you can see in this molecular ecology resources article, as well as a comprehensive article on genomic and transcriptomic analysis unveiling the population evolution and development of pesticide resistance. But if we look at globally, fall armyworm populations are known to be resistant to at least 41 active ingredients of insecticides across various modes of action groups, including the carbamates, organophosphates, pyrethroids, and some of the bacillus thuringiensis cryproteins. So this is not just for Bt proteins themselves, but also for several synthetic insecticides or pesticides that are commonly used across Africa and Asia. a robust insect resistance management program is very much an integral part of what we call integrated pest management for control of insects like fall armyworm. So IRM has to be aligned with product stewardship in terms of preventing or mitigating the onset of resistance in the populations to the insecticides, whether they are synthetic or BT in nature. And a better understanding of fall armyworm population dynamics and the resistance profiles across the Asean region will definitely help us to guide the present and future fall armyworm response strategies. But implementing this is not an easy task. It requires a holistic approach and well-coordinated and joint actions by the industry, the academia, farmers, government agencies, etc. So this is exactly what we are proposing to do in the ASEAN regional resistance management for sustainable management of fall armyworm. So as Andy pointed out, it revolves around the 3 specific but highly complementary actions. One, the regional fall armyworm surveillance and resistance monitoring. The second, of course, is country-specific and regional resistance management strategies, implementation of these. And third, how best we can integrate host plant resistance with other compatible IPM tactics, including biological control, environmentally safer pesticides, good agronomic practices, and so on. So this requires not only robust scientific data generation, but strong partnerships among academia, industry, and farmers. And most importantly, it's not an issue that can be resolved by one country. It requires a very strong regional cooperation. So no country can succeed alone. And this unless and until countries come together and work together in a coordinated way, we cannot achieve success. Coming to the host plant resistance, host plant resistance is indeed one of the pillars of integrated pest management. We can define this, as Beck did in 1965, as the collective heritable characteristics through which a plant species may reduce the probability of its successful utilization as a host by an insect species. Host plant resistance is typically 2 different actions are involved. One, you can have a transgenic resistance, or you can have native genetic resistance. Transgenic or BT resistance typically offers high levels of resistance because of antibiosis, but mostly is either it is monogenic in nature or oligogenic when you are trying to combine different cryproteins or BT proteins. Because of its high dose strategy, most of these transgenes do exert high selection pressure on the insect, and therefore it requires a coordinated insect resistance management strategy to delay the evolution of insects' resistance to that particular proteins that are being deployed in the GM crops. On the other hand, the native genetic resistance do not offer that high level of resistance. On a Davis scale, if on a 1 to 9, if transgenic resistance is around 1 or 2, the typical resistance offered by native conventional or native genetic resistance is in the range of 3 or 4 or 5. So therefore, it is not 1 or 2. But at the same time, it is polygenic. It exerts low selection pressure on the insect. And sometimes moderation helps in terms of population genetics. Moderation is the key. And it's important to delay evolution of resistance. So it has its own advantages. The efficacy and the benefits of BT maize in fall armyworm control are undisputed. Wherever they have been deployed, they did offer significant levels of protection against fall armyworm. And recent articles coming from even Asia confirm this, the importance of genetically modified maize in combating the locally prevalent insect pests, including fall armyworm or stem borers. But when you look into the different events that have been deployed in the two ASEAN countries, Philippines and Vietnam, you can see I have highlighted in red those single gene events which have been there since long. For example, Monate 10, which is Criven AB based in 2002, BT11 or Criven AB again in 2005. Monate 9034 is a combination of two different genes. So it's a stacked gene. So therefore, I'm putting it in green. TC1507, Criven F based. MIR162 is again a stacked event. So you have a combination of single gene events and stacked events for protection against insect pests in maize in Philippines. Looking at Vietnam again, here you have again BT11, a single gene based, as well as Monate 9034, which is a stacked event or a dual event. What is the relevance of this single gene versus stacked events when it comes to insect resistance management? There is indeed undisputable proof that there is a high risk of rapid evolution of resistance to single toxin BT maize by fall armyworm populations. In 2005, when Bates published this article with this beautiful figure on insect resistance management, what contributes to that in terms of high dose or refuge or resistance monitoring, regulations, cultural controls, and other IPM tactics. So this is one of the best figures that one can ever see on the insect resistance. At that time in 2005, there may not be more than 3 or 4 cases of populations, insect populations evolving resistance to BT toxins. But by 2016, this has grown to more than 16 such cases across different BT crops. So FAW, in fact, has evolved resistance to Criven AB maize in Brazil and the Criven FA-based maize in Argentina, Brazil, Puerto Rico, and the southeastern United States, as has been documented by various groups. So this is not a hypothesis, it's a reality, and it has to be dealt with. The elements of an effective insect resistance management plan therefore has to be based on several major factors. We need to learn from the experiences in other countries. We need to deploy the products in a way that can effectively reduce the selection pressure on the insect, monitor the changes in the insect's susceptibility to the expressed protein, monitor the fields for signs of unexpected levels of damage that could be due to a key target pest where it is not anticipated. And undoubtedly, there has to be a broader stakeholder participation in the development and dissemination of insect resistance management plans with a strong understanding of the local cropping systems. In all this, communications and education at various levels is the key. And there are excellent papers published on framework for insect resistance management programs. I particularly like this one coming in 2020 in Frontiers in Bioengineering and Biotechnology that helps us understand what are the lessons learned with regard to BT maize IRM programs, taking into account the Busiola fusca, the stem borer resistance development in case of South Africa. So we do need to constantly look for those lessons and incorporate them actively and in a focused manner in target regions like the ASEAN. When it comes to the native genetic resistance, shifting gears here, there is an incredible genetic diversity in the maize land races. CIMMYT's germplasm bank at Mexico holds nearly 27,000 such collections. 24,000 of them actually come from Mexico itself. You can look at this diversity, and this figure I reproduced from the one I published in Journal of Bioscience about 9 years back. You can see just from Mexico itself, there is such a beautiful diversity. You can see from a very small maize ear to one of the longest maize ears that you could ever see, almost 35 to 40 centimeters long ear of the hala in Mexico. That's the kind of diversity that you see in maize. One of the most important land races that contributed to fall armyworm resistance from Mexico is this Tuxpeno landrace. So Tuxpenos coupled with the Cuban flints or the Caribbean flints offer resistance to some of the insect pests like stem borers, post-harvest pests like weevils, larger grain borer, and even fall armyworm. A team of scientists at CIMMYT in 1980s and 90s led by John Mim, who departed 2 years back, unfortunately, developed some excellent populations like multiple insect resistance, tropical and multiple borer resistant populations using these diverse sources of land races with demonstrated resistance to insect pests. And through that, CIMMYT has derived multiple lines with insect resistance. When the pest broke out in Africa in 2016, when it is documented, by 2017, we established a very large greenhouse complex at our maize experimental station at Kibako in Kenya. There are 13 such greenhouses which offer us a capacity to deal with insect screening against fall armyworm under artificial infestation. And every year we screen thousands of materials. So more than 6,000 CIMMYT maize germplasm entries, including those from Mexico, those from Africa, were screened against fall armyworm, again validated through subsequent seasons. And this led us to an understanding of which particular inbred lines are offering resistance to the fall armyworm populations in Africa. This sort of work needs to be replicated in Asia. Unfortunately, there is no money invested by donors on such work in Asia. And this is the need of the hour. We do need to strengthen our efforts to breed for fall armyworm resistance in Asia adopted genetic backgrounds. But in Africa, where we did this work for the last 3 years intensively, we identified a set of inbred lines that are excellent in terms of offering resistance, like that CML71. You can see side by side CML71, which is highly resistant compared to CML395, an excellent line, drought tolerant line, but highly susceptible. CML338, again, excellent for fall armyworm resistance. CML574 versus another very popular inbred line from Africa, which is CML444. You can see the level of susceptibility side by side under choice experiments. So a set of these lines have already been disseminated to a wide array of institutions across Africa and Asia for them to kickstart their breeding programs for developing resistance to in their local genetic backgrounds. But what is really important is to come out with products like this, the fall armyworm tolerant maize hybrids, not just under choice experiments, but also under no choice experiments, where we partition the screen houses and each partition, each compartment is grown with only one particular hybrid. And then again, you challenge each plant with neonate larvae, at least 7 larvae per plant at the V5 stage. And you can see here excellent sources of resistance amongst the hybrids identified compared to the commercial benchmark hybrids, which are hardly yielding 1 to 1.5 tons per hectare, compared to under no choice artificial infestation, we get around at least 6 to 8 tons per hectare. In a set of 3 first generation fall armyworm tolerant hybrids are now available to partners, and these are already being tested under national performance trials in several countries across sub-Saharan Africa, including Ethiopia, Kenya, Rwanda, Uganda, South Sudan, and so on and so forth. So more than 10 to 12 countries are presently testing them through their national performance trials, and hopefully by the end of this year, and in some cases by the first quarter of next year, 1, 2, or all the 3 of these fall armyworm tolerant hybrids would be released across several countries in sub-Saharan Africa. We do need to replicate this model in the ASEAN region if we have to be successfully and sustainably controlling the pests, not just through pesticides or through other natural biological control agents, but actually coupling them with host plant resistance. So integrating host plant resistance with other compatible IPM tactics in the ASEAN. So from my perspective, there are four suggestions. One, we need to use host plant resistance in concert with other tactics. Be it BT maize, be it native genetic resistance, they need to be used in combination with good agronomic practices, biological control, and proven biopesticides as part of an integrated pest management and insect resistance management strategy. Avoid or reduce as much as possible exposure to single toxin BT crops. That can indeed diminish the durability of the BT pyramids eventually if they are deployed in some countries. If you deploy A in one country and then again after 6-7 years release B, and again after 4-5 years, if you try to release A plus B, it is bound to be much less effective than introducing strategically BT pyramids in target countries. So our suggestion is to introduce BT maize pyramids producing 2 or more toxins that are each highly effective against fall armyworm and as far as possible encoded by linked genes. If you put them in different genomic regions, there is a chance of segregation. But if you introduce as possibly linked genes in a particular chromosome, then the opportunities for segregation will reduce drastically, and you will have a better management over that linked genes. And transfer the BT-based resistance into appropriate Asia-adopted genetic backgrounds, especially those with native genetic resistance to fall armyworm and other climate-resilient traits. Remember that farmers need improved crop varieties with higher yield and multiple stress tolerance. That means once those offer yield stability and not just fall armyworm tolerance. So you enhance the probability of success of your varieties if you try to put this BT-based resistance in a native genetic resistance background. To me, that is a wonderful strategy in terms of delaying insect resistance or evolution of insect resistance. You are then combining a monogenic or oligogenic trait with polygenic resistance that is typically conferred by or seen in case of fall armyworm resistance. So that's my quick take on this. Thanks a lot, Alison and colleagues in Croatia for your wonderful support to this whole initiative. Thank you.
Thank you very much, Prasanna. That was excellent. And there was a lot covered in that presentation as well. I wanted to ask you some questions and just remind everyone as well, if you could put your questions in the Q&A box, that would help me a lot today. First up, I have a question for you here. Hello, should resistant hosts be used even in the case where the fall armyworm was not yet reported as a preventative tactic in North Africa, for example? Thank you.
Absolutely, absolutely. Even if it is not reported in a country, actually there are now practically very limited countries out there which have not reported fall armyworm. The pest has invaded practically every major maize growing country in Africa as well as in Asia, except in a few countries in North Africa or in the Sahel region. So as a proactive or a preemptive strategy, it is important to deploy, at least to begin with, the native genetic resistant varieties. And if the country has a well-evolved regulatory system, political will and commitment to deploy transgenic products with good product stewardship and insect resistance management strategy, then it's wonderful. But if not, there are options available. And those options, as I highlighted, provide smallholder farmers an opportunity to protect their crop in the event of fall armyworm outbreak. But remember, this is not a single silver bullet. Either transgenic resistance or native genetic resistance should not be considered as a silver bullet. We do need to effectively integrate them with other IPM tactics, the compatible IPM tactics. So are the other cases. Neither biological control or biopesticides, they don't work alone so effectively as they work in combination with other practices.
Excellent. Thanks, Prasanna. And that's a very important point. So I'm glad you emphasised that. I'm sure our other speakers will follow that up. I have a question here. Did you study the mode of action of the resistant plants, of the native genetic resistant plants?
Yeah. So there have been studies conducted on lines, inbred lines with fall armyworm resistance coming from CIMMYT, and as well as those lines that are developed in USDA ARS Mississippi, and those are temperate inbred lines. So in fact, some of those temperate inbred lines were derived using CIMMYT's multiple insect resistance tropical populations. So there was an active exchange of germplasm between CIMMYT and USDA ARS in 80s and 90s that led to development of lines. And these lines are compared. For example, MP705, some of the CMLs were compared with the susceptible inbred lines. And all the three mechanisms could be seen, not only antibiosis due to metabolites like terpenoids, like the caryophyllins, but also silk mason involvement in some of the resistant lines, as well as morphophysiological characteristics like very tight husk cover are all contributing to the combined effect of tolerance or resistance. So there is no one specific path through which this native genetic resistance is manifested. You do see multiple mechanisms involved, and there is no single gene or a major QTL that controls resistance in all the CIMMYT lines. Our initial studies using GWAS and now being validated through biparental populations in Africa have clearly shown that there are multiple genes involved in manifestation of native genetic resistance. We are also probing into the metabolite analysis related to resistant lines versus susceptibility. So a lot of opportunity to understand better, but initial studies show that there are multiple mechanisms involved in the polygenic resistance behind native genetic resistance.
Okay, excellent. Thank you. A question here, and I think this is going to be sort of two questions around what is your plan to distribute the newly developed resistance maize varieties by CIMMYT? And the second question to part of that is, if you have facilities now in Kenya and India, if you were thinking in Southeast Asia, is there one country, or does it not matter which country you base it in? You can be diplomatic here, but
yeah, okay, let me first answer the hybrids that we have. We are now partnering with the national partners across around 13 to 15 countries in sub-Saharan Africa, going through the national performance trials. So they are already licensed to the national programs, and once the varieties are released, we will non-exclusively license to a large number of seed companies for scaling up and commercialization. The reason why we are going for non-exclusive model is because supply is less than demand as of now. We have less number of fall armyworm tolerant hybrids compared to the demand. But as more and more products come out of our pipeline, we will also be geographically, we will be providing geographically limited exclusivity to some of the seed companies which are very strong in certain countries, so that they could be rapidly amplified and seed can reach. And by the way, if some of the Asian countries are interested in white maize hybrids, here is an opportunity. Just let me know. Send me an expression of interest and we'll partner with you in deploying them in target geographies. But what we are doing right now is transferring this insect resistance from the white maize materials as well as the yellow maize resistant lines that we identified in Kibako in Kenya into Asia adopted genetic backgrounds. So this work will take a few more years, of 2 more years at least at Hyderabad, before we come up with similar products like what we did in case of Africa. Remember, in Africa, we didn't take more than 3 years, 3 to 4 years maximum to come out with products. And we expect the similar rapid success in Asia too. But when it comes to setting up similar infrastructure, it all depends upon the ASEAN region. This decision should be left with ASEAN. Which countries are best suited to establish such a kind of an infrastructure, but most importantly, develop international public goods, not just for the benefit of the countries in which such an infrastructure is created, but for example, our Kenya facility is now helping the entire sub-Saharan Africa. If a country in ASEAN comes up with that kind of a model and says that there will be no restriction in terms of germplasm flow from that country, because CIMMYT germplasm is involved, and to any partner, any institution across Asia, that's the kind of model that we would like to go for.
Excellent. Very good. Very diplomatic and very well said there, Prasanna. Sorry. Question here is, certainly host plant resistance is the first line of defense to manage insect pests like fall armyworm. Resistant maize may initially suppress fall armyworm population. However, is there any case of fall armyworm adaptation to a resistant maize?
Since this is polygenic resistance and with multiple pathways involved in it, as I mentioned, involvement of silk mason, involvement of morphophysiological traits like trichomes, tight husk cover, and involvement of even metabolites that can repel the insects or not allow it to feed it so well, like the terpenoids. So all this means that there is no single gene or a few genes that the insect can easily defeat. So to me, it's not like a brown plat hopper resistance where there is a single gene that corresponds to one particular biotype and so on. Here there are multiple genes involved. So I don't envision that host plant resistance to fall armyworm, especially native genetic resistance, can be broken down so easily. And again, as I said, if we combine it with other IPM tactics, it's going to be even more powerful. And if you put a BTE event in a host plant resistance with native genetic resistance, then you are improving the chances of delayed evolution of insect resistance to that. So that's the reason why we considered this particular component as a key element of insect resistance management. It's not simply doing host plant resistance for the sake of it, but having a clear vision of product development and deployment strategy that can delay the evolution of fall armyworm's resistance over a period of time.
Excellent. And that's a good place to end that presentation, I think, with that strong vision there, because I think that is a really important piece of this concept document. And very well said, Prasanna. Thank you so much for presenting today, and thank you for your work in developing the concept paper with the experts and in leading that process. I'd now like to introduce our next speaker. And just before I move on, Prasanna, there are some questions in the Q&A box. If you could go in. Excellent.
I'll go through them and answer.
Thank you, Prasanna. And now it's my pleasure to welcome Dr. Srinivas Parimi. Srinivas is working as the Regional Resistance Management Lead for Asia Pacific for Bayer. And he's also the chair of the Asia IRAC, the Insecticide Resistance Action Committee. And he's been an active member of our project group on this work. And it's a pleasure to have you join us. And if you could share your screen.
Thanks, Alice. 1 second.
You're most welcome.
Let me know when you can see the screen. Okay.
I can see the screen.
Thank you. It's a very thank you, Dr. Prasanna. I mean, you made the job easier for me actually to talk about this topic on resistance management. That's a very nice introduction, and I took the liberty to answer a few questions. So you please feel free to correct me if I'm wrong there. Having said that. Resistance management is a very broad topic, and when you look at fall armyworm, it's even more bigger. And we all talk about it a whole lot, but what we can do at the ground level is practically implementable at the farm level. That's what we need to look at when we really have to take some of these tools from the toolbox. Having said that, what I would like to do in this presentation is take through few of the IRAC recommended guidelines and how we as industry kind of work to support this fall armyworm management in any geography, and with more specificities towards Asia and ASEAN region. So there are lots of products, insecticide products, and few BT technologies, which Dr. Prasanna already kind of mentioned about, that are available in ASEAN. In fact, ASEAN region is the only region where BT corn, as on date, is grown as a product, approved product. Of course, China recently coming in with its approved events. So just to focus more on ASEAN, these are some of the insecticide modes of action that are available in ASEAN. There could be many which are used, but what we recognize that have some sort of efficacy are these modes of action. And modes of action, when I'm talking about, the group numbers that are mentioned in the left side column, and these are all very important for us to understand at the farm level when you implement them. So the mode of action labeling is one of the primary activity of IRAC and crop life in the stewardship perspective. Having mentioned about this mode of action, there are very few modes of action which are actually providing very good efficacy against fall armyworm. And you can see in the right-hand side, rightmost column, how the performance rating of some of these modes of action is happening at the ground level. And this is just a qualitative indication. It does not indicate any individual product or individual brand that's available there. And it's a general qualitative assessment that the spinosines, the insecticides of ivermectin group, and diamides are the most efficacious insecticides or modes of action available for us in ASEAN today to manage the pest. Besides them, we also have few BT technologies that are cultivated. Dr. Prasanna gave a list of them, which are approved in Asian context or ASEAN context. However, as on date, there are only three sets of three technologies that are widely grown. And those are, couple of technologies are based on Criven AB gene, and there are two stacked products sold with two or more genes. And one of them is Criven 105 and Cry2AB2 based products. And the second one is Criven AB plus Criven F based products. So just to let you know that there are three different technologies that are available for control of fall armyworm when you look at the BT products. Okay. For the next couple of slides, I'll briefly explain to you how insects develop, or fall armyworm kind of insects develop resistance to insecticides. You may have seen this slide, but just a refresher to you that when you keep spraying the same insecticide, when I'm saying same insecticide belonging to the same mode of action continuously, that's when insects become less sensitive and they start surviving to these sprays. So when I'm talking about this, say you take, for example, one mode of action from the previous slide that I was discussing, and you keep on spraying the same mode of action again and again and again, you see these yellow individuals, which are these reddish color individuals, which are naturally present and in the environment. They start increasing in the numbers as we progress and come here. So the yellows and reds start increasing. And this is actually the shifts that happen. And this is exactly what we will be monitoring when we conduct a resistance management plan in a country. So resistance monitoring identifies these individuals to some extent when we really conduct studies in a region. Alternatively, the best practice would be that you alternate these applications of the one mode of action with a different kind of mode of action, which would render more protection to the crop, meaning that the insects that in general would survive the one mode of action would not survive the second mode of action, and the number of individuals that would be going to the next generation would be lower as against when they're using only single mode of action. So this way, the pest control options would be more sustainable. Let me explain to you with a kind of a calendar-based or a window-based approach that IRAC recommends. So when you look at the corn crop as such, when you divide the corn crop into different windows of 30 days, you will have a first window, second window, third window, possibly a fourth window. Okay, so pictorially, when you're looking at here, when I'm saying a window, it is equal to 30 days, which actually represents the time period for an insect to go through one generation. It may not be as precise, or it may not be so perfect. There may be overlapping generations, but the window in general is an arbitrary 30 days that is set. So when a farmer goes into the field and sprays one insecticide from one mode of action on the first day of the first window, he or she should be able to apply insecticide with a different MOA in a sequential window, that is in the second window. So when you look at the representation at the bottommost panel, the strongly recommended IRAC mode of application is that you spray one insecticide from mode of action 1 in the first window, mode of action 2 in the second window, and if possible, mode of action 3 in the third window. But you cannot keep on spraying mode of action 1 every single time you enter into the field. Okay, this is very important. We have been talking about it time and again everywhere, but the sense of it is very difficult when you go to the practical scenarios in the field level. So don't worry about overlapping generations. Don't worry about how many insects are there. If there is a sense that you need to spray and you think that that is the recommended threshold in your country, go for the first spray. Scouting and monitoring helps us to do that, which I'll be discussing in the next slides. Okay. So IRAC has guidelines that were developed a long time ago in 2016 or 18. I always kind of forget. And what we did is that IRAC International's Lepidopteran Working Group built upon this, and they came up with a new guidelines that would really help us drive, at the farm level in Asia and Africa to manage fall armyworm. So it is done in 3 steps. 1, incorporate the agronomic actions, which I'll be showing you, identify the pest, and decide when to treat. There are still issues with right identification of the pest, in spite of us talking about many identifying marks. So it's a refresher and a kind of a reminder to us that please identify the pest. Don't just jump in and start spraying it. And finally, you control the insect using IRM principles. So when I said incorporate agronomic actions, I think Dr. Prasanna touched base earlier about IPM practices. All cultural practices that you follow in a field will help dilute any kind of surviving insects that would affect the crop, not just during the current season, but also in the following seasons. Okay, so the step 1 is to keep in mind of these agronomic actions you could do. Before planting, remove all the volunteers and cover crops. You plant early with the first rains. You start scattering these planting dates in a region. You are giving a very good crop continuum to the insect to survive. So try to avoid that. If possible, get into a community approach in a village or a small city or a province and start growing or planting this crop at the same time. Most importantly, destroy the infested plant parts and crop residues. These will have a lot of resting stages or larvae sitting in there, which would be waiting to move to the next crop when it comes up. And above all, although it's easy to say control weeds, if you have a weed control options, please use them. We have seen fall armyworm surviving on weeds many places across the globe. So a good weed management and a clean field will help you reduce these carryover populations. Identifying pests, we have spoken about it. Please try to identify the pest properly. Do scouting regularly once the crop emerges. 0 to 45 days is very, very, very important time for us to do the scouting and monitoring and follow the recommended practices, whether it is IPM toolbox, from the IPM toolbox, which is including insecticides and biopesticides or biocontrol agents, whatever is available in the country. As I mentioned, you need to follow the IRM principles. I quickly addressed upon earlier how modes of action needs to be rotated. Beyond this, you also need to remember very carefully that use those insecticides that are recommended. Do not go for off-label use and illegal products, which in fact may not provide the necessary control. And so this highlights the fact that the IRM principles and IPM principles go hand in hand, and everything done under IPM will help in resistance management. Having said all of this, how do you see the success of these practices? And one of the good ways is to monitor the resistance development of pest while using all the tools in an IPM toolbox. And this is done with an effective resistance monitoring program, which this project is going to be focusing on in many countries in ASEAN. When you look at the insect resistance management using BT technologies, I already mentioned that there are 3 products based on 3 technologies available in ASEAN. One of the most important thing is the effective dose and use of a refuge. I think Dr. Prasanna already addressed about it. The key would be to use 2 or more mechanisms of action, which provides better control. I think entire industry is working very hard to address and bring products with 2 or more mechanisms of action, or modes of action, you call it. It's very important that to know that industry is working towards this, and we already have products in hand which are grown in ASEAN. We also need to do resistance monitoring, which is being done in the cultivating countries, either at field level as a performance monitoring or at the lab level. Industry also works together and does a lot of regulatory outreach in terms of refining these plans and conducting compliance surveys when the products are sold. And most importantly, we always work towards bringing new generation technologies into ASEAN. And I believe each of the industry has its own new products in the pipeline. In spite of doing all of this, the key here is to have appropriate hybrids. I earlier was addressing a question from Dr. Siva that whether we can use susceptible lines. Of course, susceptible lines are key for refuge, but it is just that agronomically they should be equivalent to the BT hybrids or BT varieties that come into the space, because that provides that agronomical synchrony for pests to develop and provide a right refuge or effective refuge in the environment. Most important, I really want to harp on this for the next few seconds, that for fall armyworm management, we should consider a holistic, multi-stakeholder approach. We have been talking about IPM toolbox continuously, but we also should be basing it upon clear evidence-based advice to farmers. Many farmers in ASEAN, except in the countries in Philippines and Vietnam, do not even know how some of the products work. And I think it is time that these products are enabled for these farmers to be kind of visit and see with their own eyes how it's working and make a decision on whether they want certain products in their country or not. Specifically to highlight here, a country like Indonesia, which has the largest corn growing acreages, I think it's very important that we see that some of these BT technologies, which are already proven, are enabled for farmers to see their performance in Indonesia. Access to technology, this again goes back to my evidence-based provisions to farmers, that regulatory system should be able to enable this access to technologies, to products and technologies in countries where they need it. most importantly, the stakeholder coordination. I strongly believe that this project and ASEAN action plan will provide a very good platform for this stakeholder coordination. I think stakeholder coordination was very important earlier in North America and in South America, and it's going to play a major role in managing this pest. We somehow need to learn how to live with it now. That's following on. So we might as well come together and join hands to build a strong multi-stakeholder approach for managing this insect. These are a few of the key takeaways that I thought I would leave it here. And although I didn't touch base upon scouting, it's very important as part of IPM to do scouting. When you have a product or a technology planted in the field, doesn't mean that you encourage farmer to sit and not bother about the crop. No, scouting is very important. And with that, I just want to stop here. And
Great,
thank you, Alison.
Thank you so much. That was very good. Excellent. Lots of information there, and I've got lots of questions coming in. We'll have to be quite quick. We're a bit tight on time, but that's okay because I'm going to be rapid fire here, Srinivas. You're going to be answering them.
Okay, I'm done. I'm prepared.
like a game show. No, seriously. Are there? Now, we had this before, and this was mentioned actually in the previous presentation, but I think this would be a good introduction to the questions. Are there any BT corn, single gene as well as stacked, reported to have become resistant to fall armyworm?
It's the BT single genes that reported resistance or is in South America and Puerto Rico, and it's to the Criven AB and Criven F and Criven A105, which actually was impacted due to the single gene resistance.
Okay.
And it's mostly in South America. Yeah.
And so I think you mentioned this, but you have, and I think Prasanna also mentioned it around these, single gene events. They are used, that BT corn, in the Philippines, and I think there was an example in Vietnam as well. Is that right? And if so, I think also Prasanna said that it's quite important to introduce maize pyramids producing 2 or more toxins that are each highly effective against fall armyworm. I mean, would that be your sort of comment? I mean, given that you have resistance that has already turned up in South America with those single events, is it important to move away from those and move to stacked or pyramid hybrids?
I kind of agree with that, and I think that's what I mentioned, that industry is working towards bringing these stacked hybrids into the cultivating countries, and that's a need of the hour. Yeah.
Okay.
And just to kind of mention there is no BT resistance reported or even close to saying that in Asia. It's all on the other side of the world. Just so that we are aware of it and be clear on that. Yeah.
Excellent. No, thank you. That's good. Here we go. What needs to be done to get universal mode of action labeling in the region?
That's pertaining to insecticides. So mode of action labeling is based on the grouping that's kind of done by IRAC in crop life, and it's universal, and it is more to the countries in each of the regions or in a continent to approve a mandatory labeling or a voluntary labeling. So in ASEAN, as on date, I believe Indonesia, Malaysia, Philippines, if I'm not wrong, Vietnam, somebody can correct me if I'm wrong, but these are the countries which have some mandatory labeling that kind of is operating now. Other countries are voluntary labeling, or there is no answer to that. But it's more driven based on the country regulations, but the universal grouping and mode of action labeling is already there for insecticides, fungicides, and even herbicides now.
Okay. Here's a question here around is how pesticide cocktails or mixtures practiced are quite common. I'm not sure, it doesn't quite make sense, by farmers. How do these pesticide cocktails or mixtures practiced by farmers, and which seems to be quite common, affect resistance management?
That's an excellent question. Cocktails means there can be one. Mixtures are generally, if they are legally approved mixtures, that's a different context altogether. But if you're talking about illegal products, yes, they bear a lot of impact on resistance management because we are entering into an area which is unknown. We don't know what that cocktail has. We don't know what that mixture has. And that would become very critical, when we look into overall management in an area. And if you're monitoring for one insecticide, whereas the cocktail has 2-3 other, which would impact the insect in a minor way or a major way, then we wouldn't be knowing it. So it's very complicated. Cocktails and mixtures, that's one of the reasons we don't encourage immediately, particularly at the illegal products level.
Yep, no, definitely. I think that's very good advice. A question here around, can you mix or rotate, I guess, biopesticides and conventional pesticides as part of a resistance management plan?
Absolutely. If they have value, why not? So it's just that, most biopesticides, you need to look at their stability and how long their efficacy or residual action, we call it, and definitely should be using it. The only thing is, if you're mixing it, please check your label recommendations and compatibility recommendations if there are any. So at times, the insecticide may impact a biopesticide. So please check for the recommendations of the product.
Great.
Particularly the biopesticide side, not the conventional pesticide.
Okay. Couple more questions here. You seem to advocate clean weeding, or I guess cleaning up residue that was left around the crop as an important fall armyworm management tactic. Doesn't this go contrary to the promotion of natural enemies?
That's a good question. So it's a choice. It's a choice, or how do I say, a balance between what do you do at the beginning of the season for weed management perspective. You don't keep on spraying herbicides to just kill the weeds anytime they come up, but at least it's a balance between what you want as a weed management perspective. But crop stubble destruction is a recommended practice in many places, and I don't think natural enemies dwell on in crop destroyed, or how do I say, crop stubble that's left in a field. And that's very important for you to consider that probably there will be more fall armyworm in it than the natural enemies.
Excellent. And I guess just before we go, I think Chris is having a question here. It was actually quite similar to the alternating the pesticide mode of actions by inserting biological control into IRM schemes. Hence, shouldn't conservation and augmentation biological control become core components of insecticide resistance management against fall armyworm? That's a question.
Well, Chris, good question as always, and like I mentioned, any tools from the toolbox which would help sustain a product is always good. And if you're talking about ecological engineering kind of, or conservation kind of tools, once we understand them better in the Asian context, where the agriculture is on commercial scale, it's not a subsistence agriculture as we see, like we see in some African countries or sub-Saharan Africa. Once we understand that, if it's working, why shouldn't we include it always?
Excellent. Yeah. Great. And there's quite a few questions left in there for you, Srinivas, if you could answer them. And there's also one from Wilma in the chat box. Wilma, if you could put them in the Q&A box, that would help. But it is very much around seeking cooperation from the industry to make the event test strip available so we can verify whether the plant damaged is in a GM field or not. So I'll let you answer that in the Q&As in the chat, Srinivas, because we have to go to our next speaker. But thank you so much for your presentation. As always, excellent, and lots of information and also practical advice. So it's perfect. So thank you very much, Srinivas.
Thanks, Alison.
And I'd now like to introduce Tek Tay. And Tek, while I'm speaking, introducing you, if you could load your presentation. I'm hoping that will be fairly easy. Tech is a lead scientist at CSIRO Australia. He has research experience in molecular, evolutionary and population genetics and specialises in applying next generation sequencing techniques to characterise the metagenomics of insect pests and to provide in-depth understanding of genome diversity in highly invasive insect pests, including fall armyworm. And that was a bit of a mouthful. So I'm going to hand it to our expert tech, who's going to explain what he's actually doing in regional resistance management related work, and it's looking a good presentation. So welcome, Tech, and we can see your screen clearly.
Can you hear me, Alison?
I can.
Okay. Thank you for the invitation. So I'm going to talk to you about the work that we're doing at CSIRO. And so this work was funded by, or is still going on, it's funded by GRDC, which is a Grains Research and Development Corporation, and also with money from other industry partners like the Cotton Research and Development Corporation and also federal government bodies, ACIR. And we have a few partners from Southeast Asia, from Myanmar, Laos, Cambodia, Malaysia, Indonesia, Vietnam, the Philippines, and also have some latecomers, South Korea and Papua New Guinea. They provided material for genomic sequencing. But in the other project partners, from these other project partners, they are carrying out bioassays as well as providing material for genomic sequencing. We also have a Ugandan colleague, Dr. Andrew Kalibi. He's looking at the management of the fall armyworms in Uganda based on farmers' experience. So the work involved testing out bioassays in the first instance, a suite of bioassays which are listed here at the bottom. And also the partners have a choice of selecting various insecticide or BT compounds to test and do the bioassay against the fall armyworms. So the Australian bioassays came from two populations, Kununurra, which is in Western Australia, and Walkerman, which is in Queensland. The Walkerman population is the first population of fall armyworms detected on maize crop that happened in around January, early February in Queensland. And Kununurra happened around March to April. So these populations were sent to CSIRO, and we use it to do diet incorporation bioassay for chlorantraniliprole, indoxacarb, amamectin, and spinetoram. And we use this to test on the second and early third instar larvae. For surface treatment, we do BT and VIP toxins on neonates. And this included commercial BT compounds, products such as Zentari and Dipel. We also do topical applications. These are on third to fourth early fourth instar larvae. Well, and we weigh the larvae so that we are sure that they're averaging about 30 milligrams each. So the results have been communicated in media release. I encourage everyone, I know there's some 180 plus attendees, to visit the GRDC portal, which is here, and see what the bioassay results are. These are in conjunction with the state government agencies such as New South Wales DPI. They also provided their bioassay results. So these are all provided. You can see what the result outcomes are from the GRDC website. But what I actually want to talk about is what we found from the bioassay results and how that help us to identify what are the other research gaps that are needed in order to better manage this highly invasive and highly damaging insect pest. So in the first instance, I want to talk about the bioassay results, but just selecting on a few compounds and compare that with published data, such as the ones that was published in 2020 by Indian researchers, and looking at the similar compounds that were conducted by the USDA Louisiana University researchers. So first of all, there are some compounds that are overlapping, so such as spinetoram. We can see that looking at the LC50, the toxicity or the potency ratio between the Indian populations and the US population, which represent the native population, so the invasive population and the native population overall, seems to have the similar response. This includes Queensland and the Western Australian population. Now, if we scroll down and look at chlorine tranilipol, we can see that in the US and the Indian population, also similar, is within a few folds of difference. So this could be explained by simple biological differences between populations. However, in the Western Australian populations, we're seeing that it's going up to about 10-fold difference. So this is getting a bit interesting because we're supposed to be dealing with a single introduction of populations coming from Africa all the way across to Southeast Asia and into Oceania. Now, if we look at indoxacarb, in indoxacarb, the Indian invasive population and the US native populations are almost 1-to-1, so there's no difference there. And the Queensland population, similarly, is about 3 to 4 folds. But the Western Australian population, we're seeing up to 40 folds difference. So this is quite significant in terms of bioassay response, the potency ratio. That means that in the Western Australian population for indoxacarb, you require 40 times as much indoxacarb to kill it. And this is unexpected for a population that is supposed to be coming out from Africa all the way across to the rest of the world, unless selection is very fast on this compound and on the populations for armyworms. This remains to be seen. Now, if we look at resistant alleles in terms of molecular characterizations, this has been done by various groups, such as by Ralph Nauman's group in Bayer. They look at Indonesian populations and they detected specific mutation in various loci for the BGSC and the ACE1 loci that are present in Indonesia, but not present in Africa, for example, or even in native Brazil populations. This could be easily explained by the fact that they were actually sampling effects. However, if we look at the literature which are published, there have been various international groups, especially by the Chinese researchers, where they look at similar mutations for the same loci. And again, in China populations, we don't see the mutation that was detected in Indonesia. This is somewhat surprising because we're expecting that the incursion went from Africa to India into China, and then perhaps also coming down to Southeast Asia. And likewise, another group from Nanjing University, which we are partners with, again, we don't see the mutation that was reported in Indonesia. So taken as a whole, this number here represents the number of individuals so far that have been analyzed for the same resistant genes, for the same mutations. And we're seeing that we're getting a significant number of individuals that are being tested, and yet we don't see the mutations that are present in, for example, in Indonesia. Now, Southeast Asian populations hasn't been fully characterized, so this will be very interesting to know what are the diversity of resistant alleles that are present in these regions. And what does it mean? I'm not going to go into this very much, except to say that as the current hypothesis, the introduction is supposed to be a single introduction involving fairly limited number of founders and therefore likely quite low genetic diversity and going across into Asia and coming to Australia. So the fact that we are seeing diversity differences and bioassay diversity response differences and genomic diversity differences suggests that there might be other factors underplaying the current observation. And it's important to understand that we might be looking at multiple introductions. So if there were multiple introductions, and looking at here where this is Australia, we can replace it with Southeast Asian countries. If there were multiple introductions, the populations are currently not at the establishing phases. They're not at the lag phase or the growth phase. They have been established. Populations of fall armyworms are around here. If there are new resistant alleles coming in, either through selection pressures or through accidental introductions, such as through international trade, we are likely to see the resistance happening, the new resistant traits spreading across the population very, very quickly. They do not need to reestablish the population because there is an established population, therefore the alleles to be spread across into the population through mating.
You have 2 more minutes, Tech.
Thank you. So genomic evidence, very quickly, we see that there are evidence of multiple introduction, and this is supported by our work with international partners such as from IRAC, from Brazil, and from China, as well as other Chinese population studies that show that there are multiple introductions. And the gene flow direction is not only from Africa into Asia, but also Asia, such as from China into Africa. So in terms of research gap, we need to understand the selection pressure. If there are single introduction, there are different selection pressure, and how are they moving into Australia, and are populations moving from Australia back into Southeast Asia under different selection pressure. Genomic approach is costly, but it's very informative. It will help us, if we can develop a SNP-based management tool, we can perhaps help the growers to understand what population characteristics they're facing. And also there is an ongoing need to understand population gene flow patterns. And Southeast Asia needs a hub for managing and coordinating all research, resistant research management strategies, including for other understanding how fall armyworms interact with other pests, and also for a way to measure the impact of the pest and management strategy. Are they making positive impact? So I'd like to thank GrowAsia. I want to thank Alison for inviting, and our funding agencies, as well as partners, Southeast Asian partners that I mentioned, and also especially our international partners from Brazil, from Uganda, and from IRAC. Thank you.
Excellent. Thank you, Tech. Really great presentation, and quite new, I think, for lots of people here who are listening, and really interesting to look at those, I guess, introduction and those pathways as well across continents, and which direction, and then how important that is to understanding how to manage resistance, I think is very good too. I've got a question here. Just in your initial work, you were looking at your research partners, and I know you have a program across Southeast Asia that you talked about. How long will it be until you get really good results that can kind of tell us, well, what's actually happening in those populations of fall armyworm? Is there resistance, and where is it?
Okay, yes, so we do have about 7 international Southeast Asian partners that are looking at bioassays, and also provided, some of which have been successful in providing us material for genomic sequencing. So the project will officially end in June. At that time, we would hope that some of our Southeast Asian partners will be able to deliver the bioassay results, and we are currently busy doing the genomic analysis. Now, it's been a challenging 12 months, and everyone would do that. It's due to pandemic, and then we have all these fall armyworms. But the pandemic is impacting on our Southeast Asian partners, especially harshly because of movement control. They can't really go to the work, or they can't be too many people in the lab doing the work. So we're not too sure yet. So we do have regular meetings, and our next meeting is to follow up on whether the bioassay is happening. Professor Andy Triciano is one of the partners, and the email from him is very encouraging. He's currently testing out the BT, and the protein have been successfully delivered to him, and he's done the the chemical bioassays already. So I think we will get at least very interesting results. In terms of Australian perspective, Indonesia is our closest partners, and having Professor Andy Triciano to be able to do all those work to help us to better prepare what's coming into Australia.
Great. Excellent. Just a quick question. You talk about the sort of genomic work and then you talk about the bioassays. What's the difference in cost and what's the difference in what you're looking for between the two, or how you can, the benefits and drawbacks, I guess, just quickly?
Yeah, so the costs are difficult to quantify in the sense that, like, if you do genomics and you have many individuals, you can usually perhaps get a special deal, and the price is going down all the time. Now, bioassays is different. You have to have the people there to maintain the colonies, to make sure that the colony is surviving, and then you need to test them. And if the results are unsatisfactory, you have to repeat it. So it's very hard to quantify the cost. But the results are also quite different, because genomic, you should have the genomic data to be backed up by bioassays. So both of them need to be conducted side by side.
Okay, great, excellent. And I was just going to ask, is Chris Dale, if you can just unmute yourself. Chris works for the Government Department of Agriculture, Water and Resources, is it? I'm going to get that wrong because I know it changes the name. And Environment. Agriculture, Water and Environment in Australia. And Chris is also the chair of a technical working committee under the Global Action on Fall Armyworm. It's the joint IPPC FAO joint committee, which I'm a part of too. But Chris, how important is understanding the sort of resistance profiles and actually then developing a resistance management plan for Australia? And how important is that to link to the ASEAN work?
Thanks, Alison, and good afternoon or good evening, everyone. It's very important, I guess, from a government perspective, as Tex sort of pointed out, that this research is all very interlinked, and importantly at the national level and at the regional level, or the state and territory or jurisdictional, right down to the farmer level, so that information flows. And we talk about surveillance and monitoring, and essentially that's a fundamental part of any national plant protection organisation, to be able to coordinate, to be able to advocate for resources and research, and to also, as has been very rightly pointed out, to lead a lot of the stakeholder coordination. There was also the reference around accessing technology and regulatory systems for permits and different technologies and systems, and that's a fundamental part of government regulatory systems. And so I think having that linkage at the national government level is really critical. We also talked about regional monitoring and coordination, and that needs to happen at the government level, government to government and regional level. And fortunately, in the ASEAN region, we have the APPC, the Asia Pacific Plant Protection Organisation, and we have colleagues here from that organisation, and that really brings together all of the chief plant protection officers who have the responsibility at the national level to coordinate. So I think it's really critical from a government perspective. We want to collaborate as much as possible with research institutions, R&D organisations and facilities, but also advocate very strongly and lead at that regional and international level. And that's one of the real opportunities that we have through the FAO and the IPPC work.
Great.
Thanks, Alison.
Thank you, Chris. And Tek, I'm going to leave you now, and thank you very much for your presentation. Excellent, and I'm sure there'll be lots of people poring over that tomorrow to work out what's actually happening. You have a question in the Q&A box. If you could just devote a little bit of time to answering that would be great. And I will move on to our next speaker. And it's a pleasure to introduce Dr. Silvana Paula Moraes from the University of Florida, where she's assistant professor. I think it's maybe 2 a.m. or something terrible in the morning. And so she's really made a huge effort to join us. But a huge thanks to you. Her research focuses on general area of applied insect ecology and host plant resistance, crop environmental manipulation, and characterization of the risk of invasive pests to cropping systems. But she also addresses biology and behavior of insects as applied to insect resistance management with a focus on insect movement, host utilization, and differential exposure to Bt toxins. And I already noted she knows lots of people in the room. I could see her saying hello to Tech and others before. So obviously not a stranger in this discussion. Thank you very much, Silvana. You just need to unmute yourself.
Can you hear me now?
Excellent.
Okay. First of all, thank you so much for the invitation to participate in the event. I'm really glad that I had a chance to be here. Right now it's 3:25 a.m. in the United States, in Florida, but I'm glad that I had a chance to be part of this discussion and attend so many excellent presentations so far. So when I was putting together this presentation, we had so many topics to talk about FAW armyworm, but I decided to highlight especially some results of research I have done. And important to explain, I have been working with FAW armyworm first in Brazil. I am originally from Brazil. I used to be a research working in Lepidoptera in row crops. I did my PhD in Nebraska, in north of the United States, where I also had some chance to see FAW armyworm arriving late of the season. And since 2016, I have been working in Florida in a transition zone between tropical and temperate area. So I can say that I have been seeing FAW armyworm in different crops, especially row crops, maize, cotton, even soybean in my region now. And my work, as you mentioned, it has been dedicated to develop different IPM tools and also insect resistant management recommendations using insect ecology studies. So, as I said, I work in Brazil. When I returned from my PhD to Brazil, I saw in firsthand the resistance to Bt crops, Bt maize, especially Cry1F maize, resist of FAW armyworm. Cross resistance has been also documented to other Cry1 base maize hybrids. Cry1AC never was a high dose event to FAW armyworm, and I mentioned Cry1AC because it's not in maize, but is high adopted in cotton. And FAW armyworm, especially in South America, can be a real problem also for this crop beside other hosts. But I should say that I believe that the technology, it is an important tool in the IPM. I believe that is not a silver bullet, but it still has been contribute for the management, not only FAW armyworm, but other target species. What is really important is to put in consideration an insect resistant management program that can avoid all the problems that I saw occurring in Brazil. When we talk about resistance and when we talk about the effective insect resistant management, not only for FAW armyworm, but my focus here will be in FAW armyworm, we need to put in consideration genetic, ecological, behavioral, and operational factors when you're adopting this technology. And I also will be touching base a little bit about use of insecticides against FAW armyworms, because sometimes it is a tool that it is important to be considered in different scenarios. And I'm not going to talk about genetics here because of the time, and some my work in genetics is also especially in collaboration with other research. And the focus here will be especially in ecological, behavioral, and operational factors for FAW armyworm. First thing that I believe is really important to a clear understanding of the pest occurrence phenology in the area where we are planning to adopt any kind of management against for FAW armyworm. Here in Florida, you can see a graphic of pheromone trapping. I have been seeing trapping FAW armyworm since I started my program here. I have done the same previously in Brazil. And this information, in my understanding, is critical in order to understand the phenological occurrence of the pest in the landscape, agricultural landscape. This provides information about the critical time of pest pressure when it's time to go to sampling fields, and also provide information where we should be looking, especially crops that can be more susceptible in the landscape. As you can see here, we have been documented, surprisingly, the high pressure FAW armyworm in the region where I am is a transition zone, as I said, between tropical and temperate area, is especially beginning of the autumn, the fall, when we have a huge population, especially migrating to my region. Important to say, FAW armyworm, as far as you know, doesn't diapause. So migratory populations every year reach north of United States and my region. But for example, in Brazil, when in South America, the species is present all year long in the region because it's a tropical region where we have the cultivation of the crops all year round and host available for the pest. And my pheromone trapping, as I said, has been performed during year round. And the idea is really to document the populations, the occurrence, and also I have been documenting the presence of different strains, something that I don't know how much makes sense in Asia, because some studies has been indicated that there are differences in the genetic of the populations that you have right now. Another important information that I think we need to be put in consideration when developing insect-resistant management is related with FAW armyworm oviposition pattern. In 2014, a paper was published saying that months of FAW armyworm may have a preference to BT plants because of the injury in OBT plants. We designed a study in order to see the difference, if there was any difference in preference, and our results in greenhouse and even field level indicate that there is no distinction of BT and OBT maize plants. And months doesn't discriminate site for oviposition, consider the damage in the leaves. This is important information because when you think about recommendations for refugee area, the presence of damage in refugee areas cannot compromise the existence of unselected populations in the area. Besides that, we did studies related with the larval movement on plant and plant to plant in order to understand the occurrence of the plant, the FAW armyworm on the plant in different moments of the crop development, and also the level of exposition of the larva when moving on the plant, consider the different expression of BT toxins in the different tissues of the plant. And larval plant to plant movement, we also document how far FAW armyworm move around, information also that can help when designing refuge recommendations and especially distance between strips of BT and OBT corn. Besides that, in 2019, not 2018, sorry, the citation is not correct, we did a literature review in order to list all the host plants associated, reported in literature with FAW armyworm. We found more than 300 plants that can host larvae of FAW armyworm in 76 plant families. So our study also with live table parameters indicates a huge biological plasticity of this species The number of the insects can be variable, depending especially of the temperature conditions. And this defines success of establishing a FAW armyworm. And this is why these pests can be so aggressive, because it's specific about this biological plasticity. Something important that we need to consider also is that FAW armyworm is not only a year feed pest, it can be also a pest during the vegetative stage, even causing dead heart, as you can see in the slide. So we come back again about the information about the occurrence of the pest in the landscape, and when is the critical moment in the region, in your region, when you can have the occurrence of the pest and you can design the tools, the management tools that you'll be adopting. We also believe that is important when you're defining your insect resistant management is to list the key pests associated with the region. FAW armyworm is now an invasive species in the region, but other species already exist in the system. When I talk about other Lepidoptera or the caterpillars, the interaction, the interspecific interaction between these species can define which species, which pest will be predominant in the system. So we know that usually invasive species used to be extremely aggressive because they are new in the system, they do not have natural enemies acting as mortality factors, etc. But I really believe that it is still important to keep on mind that in FAW armyworm will interact with other species. Just to give an example of several works that we performed in Brazil during the invasion of Helicobacter pyrgida was to understand how Helicobacter pyrgida will be interacting with other lepidopters already present in maize, in cotton. And what we saw was a extremely competitive advantage of FAW armyworm in that case over Helicobacter in general, corneal worm, Helicobacter zeae, and Helicobacter pyrgida. And in the absence of competitor, FAW armyworm also has advantage in the development. The larva of FAW armyworm is not that aggressive, but when they go to fight, they have a higher chance to survive over, for example, Helicobacter pyrgida. So I believe this is really important to put in perspective the inter-guilder competition and what you expect to be predominant in your region, because this can define the tools that you'll be adopting. Something else that I know that there are a lot of discussion in the use of biological control, apply biological control against FAW armyworm. But I think it is really important also to document the natural biological controls that can play an important role in the management of the insect and reduce the pressure of the population. Just to give an example, in Florida, we recently published a paper where we documented the predation effect of red important fire ant. This is an invasive species, it's a pest in urban areas. And we realized that in agro-ecosystem, in the fields like cotton, especially in peanut, this species, red imported fire ants, it is an important natural enemy against lepidopters such as FAW armyworm and Helicobacter. So I'm not specifically talking about fire ants in your region, but I think this is just an example how it is important to understand the system and identify natural enemies that provide natural biological control, and somehow you also can incorporate when designing your IPM and your insect resistant management program in order to, for example, adopt selective insecticides or even provide some techniques that can improve the development of these natural enemies in the system.
2 minutes.
Okay, so insecticide susceptibility monitor, we talk about, I'm not going to talk about susceptibility to Bt toxins. This is an important point. I really call attention how it's important to coordinate with different segments, especially in industry, in order to provide toxins. For monitoring of susceptibility, it's really important to have reliable colonies. In the United States, we are lucky enough to have companies that you can buy susceptible colonies. I think it is important to have an organization in different research, in different institutions in order to keep these colonies in lab. Colonies of Lepidoptera is not that challenging because you have natural artificial diet, but there are some safety requirements like avoiding contamination of the scales in the environment, so demand some cleaning environment, etc. And here, just to show what we have done in the Florida Panhandle, this work was published last year, that we have been documented susceptibility to insecticides. Here I show bifenthrin, a pyrethroid, and a diamide, chlorindiniprole, and different insecticides, 2 insecticides against different species that we have been seeing predominant in the system. And doing that, what we can see is that the expected mortality. Sorry, can you please silence your microphone? Okay, I'll keep it going. So here you can see in the result what we are able to do doing curves of dilutions. We are able to document and calculate the expected mortality of each species for the populations that we collect in different regions. In the case of FAW armyworm, we're still doing the same. This is a work just about to be submitted for publication for Spodoptera exigua, beta armyworm, but we are doing the same for FAW armyworm. And we need to keep on mind is about the stability of resistance and keeping populations, resistant populations in the lab. We have been documenting the susceptibility and how the resistance can be stable through the time or not. And this has a extreme importance when we are recommending, for example, rotation of mode of actions, because if you have resistance that is stable through the time, rotation of mode of actions cannot be in recommendations when you have case of resistance. But still, what I'm trying to say here is how important is to understand the susceptibility of the populations and perform different studies, and also, as Tick just presented, using also molecular markers in order to detect some difference in the susceptibility and markers that can indicate this source of resistance. One last thing I would like to talk specific about insecticides. When you talk about, we think about use of insecticides against FAW armyworm, is how important to understand the behavior of this species. There is a short interval control window before larvae establish, especially during the reproductive stage. Key points when you adopt insecticide, it is coverage of the feeding sites, a spray volume, and the flat nozzle that really helps to target specific areas of the plant, especially the worth of the maize. But rotation of mode of action has been presented here, and selectivity of insecticide. And coming back what I mentioned, identify the natural enemies prevalent in the region can also help you to select the best options for your region. So putting everything together, if I can summarize.
Quickly, Silvana.
Okay, summarize here. I think that insect resistant management needs to be in IPM framework. We need to combine management tactics. Something that I don't have any doubt to say is that one size does not fit all. We need to put in consideration region-specific information. You need to know your region because there are differences. Different aspects relate with the spatial temporal dynamic of the crops in your region. Besides that, the ecology of the pest, besides the genetics and also behavior of the pest. Monitoring system, it is critical in order to understand what's going on. And one last aspect here that I don't know how much will be discussed, and I'm not a specialist on that, is understand farmer behavior. In my experience, I saw for example, the adoption of BT technology, the recommendations for refuge demands understanding for everybody involved in the process, coordination, and clear recommendations of insect-resistant management tactics in order that can be adopted and can be successful. One classical example is the recommendations for refuge areas, structured refuge areas, and in the case of insecticides, rotation of mode of actions, because all these components can contribute for a successful long-term insect-resistant management program that can decrease the impact of a so aggressive pest as is FAW armyworm.
Great, thank you so much, Silvana. That's an excellent presentation. Actually introduced lots of new material as well for people to reflect on. I'm going to ask you about 3 or 4 questions because we've got to move on, but I have a question here, and it is, the question is, the presence of fall armyworm in Ghana has helped to diminish armyworms, I guess other armyworms, and what might be the possible reasons for that?
I would say the increased use of insecticides, maybe, or maybe farmers more aware about what's going on and be more precise when adopting management against FAW armyworm, and indirectly also manage other insects. And of course, interguild interaction, because we saw this happen. I saw this, for example, in Brazil, in specific landscapes where we have a predominance of FAW armyworm over Helicoverpa armigera, that in that time was invasive species in FAW armyworm. Besides that, population of natural enemies that can get a lead.
Just carrying on from that sort of intra-guild competition, do you think, I think you said they have do they have a preference, or do fall armyworm have a preference for damaged leaves or already damaged leaves? Do you find, or does it not matter? So for example, is there any interaction between where a plant has been damaged by another insect, which therefore makes it more attractive for the fall armyworm? Have you seen that at all?
I haven't never seen that, even though I see difference in the feeding. For example, when you compare FAW armyworm versus Helicoverpa genus, Helicoverpa can, for example, in cotton, they have a tendency to migrate inside the, for example, the cotton boll, and FAW armyworm, what I have been seeing, are more superficial feeding, sometimes preference flowers around, but no.
Okay, quick questions. One will be very easy. Actually, both will be very easy, and then we'll move on. One is, does fall armyworm larvae exhibit cannibalism? Is the first question. And the second question, you talked about a short interval control window before establishment. I guess that control window, that is very important to get in there fast. How long is that window, in your opinion, or in general?
Okay, cannibalism, yeah, extremely cannibalism. And this is one of the issues when you are having colonies, because it takes more work to keep them separate, especially after the second Easter. Regarding to the window, is really important in my understanding to establish a system of, for example, pheromone trapping when you start to see the fly, because once you have the eggs deposit, I would say, depend of the temperature of the region, you have 3 to 5 days before you have neonates emerging and starting feeding and finding sites for feeding in the plant. So, yeah.
Excellent. Very good. And that's actually really important information, that management window. So thank you so much, Silvana, for joining us. I mean, it's been fantastic to have you, and it's really important to have that perspective, I think, from somebody who has been involved in a different region. And we haven't actually heard from somebody from the US or with experience in Brazil yet. So that's been fantastic. So thank you very much.
Thank you.
Thank you. And I'd now like to introduce our final presentation today. We may run 5 minutes late today, I'm afraid. I apologise for that in advance. But I do want to introduce Dr. Kongming Wu from the Chinese Academy of Agricultural Sciences, where he's Vice Chair of the Academy. He's published as an author and co-author a significant amount of research with a growing focus on fall armyworm since its arrival in China. And CAS has contributed to many of our sessions across the ASEAN Action Plan, sharing their extensive work. And it's a pleasure to have you join me, Kongming. Can you see your presentation?
Yes, that's okay.
Excellent. So you just tell me when you want to move to the next slide.
Yeah, so I'm very glad to have this opportunity to introduce so IRM for armyworm in China. So what I want to talk including two aspects. The first is armyworm resistance monitoring. So after the armyworm invaded into China, so we do want to know what kind of resistant gene this pest carried. So we use genomic study, try to understand this. But the problem is we don't know how many gene mutation related to this resistant evolution. But still we find there's some mutation based on the publication. So you can find for OP insecticide, carbamate insecticide, we can find the pest invade carried this resistant genes. Next, please.
Oh, sorry.
Yeah, so for traditional monitoring is so we use this regular assay to test the resistance. We can find most chemical the pest already produce resistance. So just we find several new chemicals. Still, it's very effective to this invade pest. Next, please. Yeah, so people are so much concerned. So the BT resistance, in China, so we also use another of BT pesticide. So we do want to use this BT transgenic cotton to manage the pest. So by assay, so we find the regular, the transgenic, they express the protein, the toxin, the carrier AB, carrier 1AC, carrier 1F, carrier IAB, and website. So we compare this the dose to the US baseline. So we can find the invaded population. So it's still susceptible to the most the BT the toxin. Next, please. Yeah, so for emergency, control, China, by our monitoring for the resistance. So we recommend some the chemical to use for control the pests, particularly for resistant management. We require the farmer to use different mechanism chemical to take rotation use, as well as to mixture different mechanism chemical. Next, please. Yeah, so China, just last year we rapidly register several the biopesticide, including the BT, to recommend to farmer to use this biopesticide to replace some of chemical. Then we wanted to decrease the pressure from chemical, to delay the resistant evolution speed to chemical. Next, please. So another important factor is we find that if the larva developed developed into more than the third instar. So the chemical resistance, so it's will increase quickly. So that's we need to guide the farmer to use pesticide to control the armyworm. So and just in the armyworm just hatch so period. So China, so we develop so armyworm information system. So this system can forecast the population dynamic where so the population migrate to so how so population density and what time to spray pesticide. Next please. For our early warning system, so one thing we must do is to dissect the female mouse to understand so when the female mouse will produce, will lay eggs, then to forecast this, to predict this, to ask the repair farm to spray in the egg stage and also in the first and the second instar stage. In this stage, so I think so both chemical and biosecurity is very, very effective. Next, please. So about so BT corn. So China already so develop domestic BT corn. So field trial so present indicate this the BT corn so have a great
I've just lost Kongming, so I'm hoping he will come back.
yeah.
I'll just give him a few more seconds.
Okay.
Kongming, can you hear me?
Yes.
Okay. I can't hear you though. Is there someone else? I've lost my no, I think everyone may have lost you, Kongming.
I can hear you.
Oh, there we go.
For me, it's not,
now it's clear. Carry on.
Yeah. No. Yeah. Next, please. Yeah. So China still, so we have don't take any decision to commercialize. So this BT maize, but just take the field study. So we think so the BT variety, so it's on the table. So if we decide, so we can use to manage this pest. But for IRM, so we take the study to establish a model to forecast the resistant evolution speed. So we think so based on our product, so now so we use 2 BT gene plus 20% structure refuge. So we think this 2 gene and refuge maybe so it's a good strategy. So also so we prepare so this to follow the BT corn commercialization. Once government take the final decision, so we will take this strategy to manage this pest.
Excellent.
So I'm very glad to have this opportunity to introduce Chinese so the case study. So we think the armyworm, so it's a regional pest can move from one country to another country. So China, so we are so pay more attention to work together with so Asia, South Asia country to manage the pest, to manage the population. So we hope so the Asia can do more thing to organize so the different countries together to control the pest, to guarantee so the maize the production. So thank you very much for your attention.
Thank you so much, Kongming. That was an excellent presentation. Right on time. We are going to just be 5 minutes late, everyone, but I just want to ask Kongming maybe 2 questions. And I see also, Tech, if you're there, there's a question for you in the Q&A box as well. Kongming, firstly, you have this monitoring system which looks very good with 8,000 early warning reports of fall armyworm out to farmers. How quickly does that get to farmers, those messages?
Yeah, so for China, so for this early warning system, we have a 3 level. So for short level, just in 1 week. So for middle level, it's 2 weeks. For 3 level, it's for so the long term level, it's about 3 weeks. So mostly, so we can monitor the mouse migration and the mouse population in the field. Then we based on the mouse population and produce alga. Then to give farmer so the guide the information. So I think maybe in 1 week.
Okay. You mentioned also that you have 3 biopesticides, I think, on your slide. And the idea is to use more biopesticides along with or with less conventional pesticides. How easy is it to get farmers to use those biopesticides and to use them properly? Do you have to provide lots of information, or do farmers adopt the biopesticides quickly?
I think still in China, so it's a great challenge. So compare with so the chemical, the controlling efficiency from biopesticide it's much lower. So the farmer, so especially the small farmer, dislike so the biopesticide. So for China, so government, so we will give some money, some fund to support so the small farmer to I think so just give some special policy.
Okay, good answer. Here's one question here, and then we might close. But the question is, with the application of myco-insecticide against fall armyworm, does this or has this been impacted by UV radiation in China?
I'm sorry, could you repeat your question?
I'm not sure myself, but application of myco-insecticide against fall armyworm, does this or is this impacted by UV radiation in China? Not sure that makes that much sense, but I've got another question for you, perhaps, and it's about the BT corn. So at the moment, the government is considering the BT corn. Is that right? And you said they need to decide whether they will implement it. How? I mean, I know you don't know, but how long does that take in general?
So we already take so this field trial for the BT maize. So about 2 years. So efficiency, so it's very high. So I think this information already so give so government, but no one knows so how long and what year so government take the final decision. But I think so it's a potential option.
Okay, excellent. Thank you so much, Kongming. Once again, fantastic presentation. It's great to have you and your team supporting our work and inputting into many of our programs. Fantastic, and thank you for sharing your time with us.
Thank you.
Thank you, Kongming. And I'm going to introduce Andy back now to give a quick summary. And we're going to be 5 minutes late overall, which is not too bad, really. I apologize for that. But Andy's going to be very brief with his summary, I'm sure. Andy, all the pressure is on you.
Well, thank you very much, Alison. I think it has been a great workshop covering the from the molecular aspect to the field practices of resistance management. I noted 100 participants attended this workshop, and with a lot of questions and comments. I think it's just the importance of this topic. I think the next question is, so what, and what is the next step that we are going to do. So there are 3 steps that we are going to do in the short time. The first, we will be revising the concept paper based on your feedback. So please, you can download the concept paper at the address written on the screen, or you can wait until Alison send an email to you, because I think it was mentioned in the chat box that Alison will also email to you about the concept paper. And please provide the written feedback on the concept paper and send it to faw@proasia.org by the 1st of May this year. Second, secure funding and develop the work plan. And the last one, we will be presenting the final concept paper after we finish revising to the Asian FAW armyworm task force on the July 13, 2021. So thank you very much for everyone for involving in this workshop. And thank you, Alison. And I turn the floor to you.
Thank you very much, Andy. And I'd like to say thank you to all our speakers today. Wonderful presentations. We virtually kept on time. We're only 5 minutes over, but what a wealth of information, resources, and I guess just like good hints on what to do, good tips to share. And I'd like to thank you as well, the participants. I think we actually did get up to 180 plus, actually 200 plus in the end for the workshop. Please make your comments and I will send you the email as Andy said. And take care, everyone. Please have a good morning, afternoon, or night, wherever you are across the world. Thank you very much for your time. Bye.